This is 8.2 practice C number 12, and I need to graph this function and state the domain and the range. So to graph it, I'm going to use my 4 steps. There's more than 4. Sorry about the bell. Depending upon the function, but in this case, I'm going to follow my step. I want my Y-intercept, my X-intercepts, maybe plural. I want my vertical asymptote, and I want my horizontal asymptote. Those are the points that I'm going to plot. Then I'm going to look at it on a graph. So let's start by finding the Y-intercept. And if you remember, when I have a graph, every time I intercept the y-axis, my x value is 0. So to find the y-intercept, all I need to do is put 0 in for x. So that's 4 times 0 minus 8 over 7 times 0 minus 2. So that's equal to negative 8 divided by negative 2. So my y-intercept is positive 4. So I'm going to first mark that right here on my graph. Positive 4 is my y-intercept. I'll even put it here, equals 4. My x-intercepts are where y is equal to 0. Right? X-intercepts are where y is equal to 0. So I'm going to set my, I'm going to set my y equal to 0. So I would have 0 equals 4x minus 8 over 7x minus 2. And the only thing I'm concerned about, really, is that my numerator be equal to 0. Because if my numerator is equal to 0, then my y is going to be equal to 0. So I have 4x minus 8 equals 0. I'll add 8 to both sides. I have 4x equals 8. I have x is equal to 2. So I have an x-intercept at 2, 0. So 2, 0 is my x-intercept. Now I need to find my vertical asymptote. Well, my vertical asymptote is what makes my domain, my vertical asymptote is what makes my denominator equal to 0, because I can't have any points there. So 7x minus 2 equals 0, 7x equals 2, x equals 2/7. That is my vertical asymptote. And I'm going to sketch it in. Well, 2/7 is kind of a weird number here, but I mean, I can estimate it good enough. I'm going to put my dotted line right there, and that's close enough to 2/7. And it's especially close enough if I label it x equals 2/7. So I'll put that in here. This was equal to 2, and this was equal to 2/7. My horizontal asymptote, and just one more thing on the vertical asymptote. The vertical asymptote is the value that makes my denominator 0, because I can never cross a vertical asymptote. And as x gets closer and closer to that number, as x gets closer and closer to 2/7 on this graph, my value of that function is either going to go towards infinity or negative infinity, but it'll never be able to touch that vertical asymptote. Now, as far as a horizontal asymptote is as x approaches infinity. So if I had, let's say x was equal to 1,000,000, which is a pretty big number, but not that much next to infinity, I'd have 4,000,000 minus 8 divided by 7,000,000 minus 2. And you can see with the size of these numbers, 4,000,000 minus 8 over 7,000,000 minus 2, the 8 and the 2 are really not that important in this calculation. They're very tiny. And the millions are going to cancel out. So I'm going to be approaching the value of 4/7 as x approaches infinity. As x, and if I had, if I'm not even talking about millions, but I'm talking about, say, billions, or even bigger numbers, the 8 and the 2 are even less important under those circumstances. So when I'm trying to find the horizontal asymptote, what I'm concerned with is the leading coefficient of my numerator and the leading coefficient of my denominator. Leading coefficient meaning in standard form. So if this equation was written f of x is equal to 8, negative 8 plus 4x over 7x minus 2, my leading coefficient of my numerator is still the 4, because it's in standard form, it's still 4x minus 8. So my horizontal asymptote is going to be 4/7. Okay, let's go back to our graph. I'll say my horizontal asymptote is equal to 4/7, and I'll graph that in. That's a little bit more than a half, I think. So I'll go right like this, and I'll label it y equals 4/7. Well, once I've got that, then I can go to my calculator. And you have to have those points there. And you'll notice in this particular graph that one of my intercepts and my other intercept, they are on different sides of the vertical asymptote. So they're not going to actually ever be, they're not going to be connected with any part of this graph, as you'll see in a minute. So I put it into my calculator, 4x minus 8 divided by 7x minus 2. Use your parentheses. If you don't use your parentheses, you're not going to get the right number. And I'm going to go zoom 6, and I graph it. And it looks pretty much like I would expect it to look. I think I'm going to expand it a little bit, or I'm going to zoom in on it a little bit so I can see where it's connecting a little better. I'm going to go negative 4 and 4, and I'll leave it at negative 10, 10 and see what that looks like. So there you can see, it looks like I have my vertical asymptotes proper, my horizontal asymptotes proper, and I'm going to make my graph go like this. I'm following the asymptote, and then it's curving up. It's going through my intercept, but it's not touching the other asymptote, not touching the vertical asymptote. And for my other branch, again, I'm going to go through the intercept, and I'm not going to touch the asymptote. And if you do that, then your graph is done. It's complete. I should label my points. This point here is 2, 0, and this point here is 0, 4. So you label your points, label your asymptotes, draw in your branches like they're supposed to look, and that is a correct answer to this problem.